Hello everyone. This is my first international conference in English and it's not my native language, so I try to make my best effort. So my conference is about Senior Smith, a web-based radio frequency Smith chart app using JSXGraph and JessieCode. As you say, JessieCode is a not too very known element of JSXGraph, but in this case we'll talk about it. So this is the agenda. We wanna talk what is a Smith chart, what is the problem that I want to solve with this application, the first solution that I made, the Senior Smith as a product, and the future. Okay. First, if you know, maybe no one knows, only the electrical engineers, Smith charts or telecommunication engineers. Smith chart is only a transformation of the complex plane. So we are familiar with the plane when we have a x-axis that is the real part and the y-axis that is the imaginary part. So what we do with Smith transformation is this. We twist the plane and make the infinity near and put in the left part. So here you can see it. You can see it here. So the infinity this is the complex plane that we move and put in this shape. So this is transformation. So we can put whatever a complex number here and make the transformation, and this is the result. So we add some elements like numbers and make some fixes, and is used for calculation of some radio frequency circuits like transmission lines, amplifiers in very high frequency, and so on. Okay, so the current experience with the Smith chart is this. So you need to use a pencil for draw some circles, make some intersections, use some compass to make circles. You can use sometimes some element to measure angles, some rules, but in general you are using an old school way to make things, and that is correct because this is a very recent in the history of the humanity invention, like the 19th century. But as you can see, it is before the use of the invention of the computers. What is the problem with that approximation? Even in the academy or in the industry, you need to use the Smith chart for some calculus. Not all, or not the most complex calculus, but you need to use it. And is not rare that in the universities you can learn that. But the problem is an old school way to do things. The first problem is a fixed graph. So if you draw something in the Smith chart, you cannot change it unless you erase the things and begin from scratch. So it's not so good. You have a tremendous loss of precision. So if you use a ruler, the compass, and make a sequence of calculation, graphical calculation, remember, it's graphical tool, in the end you will get the result, but can be a lot of errors that accumulates from the beginning until the end calculation. Okay, you have not too many colors, so the first color is the gray of the pencil. You have some other pens, but that's all. And the analytical way is so complex. So this is a graphical tool, but you can make the same with calculus, with some equations. But the problem is that you need to make use of some trigonometrical or hyperbolical functions and a lot of formulas that are very complex to be useful in general. So the question is how we can use technologies and cool graphics tools to make Smith chart the same fun and educational, because this is not only a professional tool, it's a educational tool. So in the market, in the state of the art, you can find a product like 3D Smith chart that is more complex than the 2D Smith chart, but is as well very useful. But the software is so complex to use for students or even professionals. It's very specialized. You can find a quick smith that is the problem with quick smith is very highly coupled. Is highly coupled with circuited elements like capacitors, inductors, resistors. So you are not using the full potential of the graphical calculation that you can make with a paper and a pencil. You need to choose some elements, and that's all. And you can find some other kind of software like Linesmith that is not so modern in the interface and the use. Has the interface like a very old interface like Windows 95. So why I begin doing that? I begin doing a senior Smith was a problem in a subject for my university. I study electrical engineer. So in a telecommunication subject, I needed to pass an exam, and the professor allowed us to use the Smith chart with pencil and paper, of course, but also allow us to use the computer to make other calculation. But because the telecommunications calculation is very complex, you cannot use only the calculator, the pocket calculator. You need to make the use of computers. So I take advantage of that and say, hey, what if I put SFG of a Smith chart in GeoGebra and make some functions to calculate the transformation between the Cartesian complex plane and the Smith transformation? Why I cannot make a useful tool to make my calculation in the exam? And that's what I did. And it's very successful because I spend a little more time in general to be efficient with the tool, but compared with my colleagues, I made the calculus more faster and more precise, more precise. So it was a good fit. So I passed my exam and continue my life, but that idea keep in my mind, and I decide to to make a senior Smith. This is a product that was first the undergraduate thesis in my engineering, but in this moment I make a lot of effort to make more useful for the people in the world. So Senior Smith is a modern web app that updates the traditional Smith chart for the two items. It offers to the radio frequency engineers, teachers, and students a fun way to analyze circuits, like I mentioned before, GeoGebra. In, and this can be used for calculate impedance matching networks, S-parameter circuits, radio frequency amplifiers, transmission lines, and other great radio frequency applications. So if you want to try in this moment the app, you can go to this URL. I will copy. No, this is not possible. The chat, okay. Put in the chat. Okay. Okay. This, of course, as you know, use GSXGraph for make the graphical part, but also use JessieCode to make the code part. So I will explain that after. And my principal objective is to make the use of a graphical canvas or the Smith chart in a geometrical way, not circular way, a geometrical way that makes some challenge and trade-off. You need to know what a circle means in a Smith chart. So the circle means, for example, a relation between noise and signal. For example, this circle, this line means an angle, and so on. This kind of circles that is you can see here is inductors or capacitors, but you need to know that. But it allows you to use the full flexibility of a graphical tool like GSX. So the other part, in the interface you can see, we have some elements. As you know, the GSX graph is only a library. So I needed to implement a lot of other tools to make this usable in a user interface way. So I made some elements like delete and undo, change the coordinates reference. I will show you after. Make some elements, toolbox elements like you can find in GeoGebra, but the basic like the point, the line, the segment, the line, the circle with center, the arc, but some additional that tools that only can be possible in Smith chart, like the imaginary circles, the real circles, the imaginary circles, the uh, the other part of the Smith chart, the impedance circles, and some angles. Okay. I also challenge the I have the problem to implement a grid, not only the Cartesian grid like you can see here. I needed to implement the Smith grid. So I need to hack a little GSS graph to make that possible. And to hack another things like put the toolbox when you to stylish the toolbox when you hover the points, the circles, and so on. So I will show you. This is a Smith chart, senior Smith, sorry. You can see the canvas here, the code here. This is JSCode. JSCode, I don't know if all of you know about JSCode, but it's a simplified JavaScript, a domain-specific language made for make more easy the use of GSX. So this is good because this tool is not only for programmers, it's for people that are studying engineering and maybe they don't program. But it has the enough parts to be useful, like you can make for's, you can make conditionals, put the elements, but that's all. Not so complex, not so basic. So it's perfect. It's a perfect fit for this kind of application, and also has a very good feature. Is this? So for example, here this element that you can find in the canvas, but here is the properties of that. So in this case, the color is I put a color, I put some faces, the size, the fill color, and that element is this element here. also makes the use of the split the color syntax and the split some each element. So you can see here that, for example, this element has 3 lines in the code. So the application can identify the elements and split correctly. Also recognize the colors in the properties, so you can check before use it. So for example, blue here is the renderization. And it also check for errors. So in this case, sorry, this is a new version. When you run this, try to run this, they is not valid, so it's an error. Okay. Also, you can define functions, methods, whatever. So, as different of the Smith chart, the paper Smith chart, you can make change in the parameters. So, in this case, I can move, and all the parameters recalculate. So, for example, here I move this point, and the info toolbox is different. So you can see here that is recalculate the numbers, and it shows you a very specific parameter like impedance, the real part, the center, the real the radius of the circle, and other. It depends of the element that you select. So in this case, when I select a circle, it only shows you the radius and the center. But when you select a imaginary circle, they show you the imaginary part, the radius, and the center. And when you select a point, for example, this point, it shows you the transformation, the values in the transformation, the Smith chart transformation, the Cartesian value. So in this case is minus 2, minus 0.2, and minus 0.3 here. The real part, so is the distance from the origin, and the angle. So, for example, I move the angle here to 90 degrees, 180 degrees, and so on. And of course, you can make a new element. So when I put, for instance, a point, it creates the point here in the end, here, with the coordinates. But in this case, as you see, it's a S point. So it's a new element I need to create to be able to calculate the Smith transformation. So in this case, it's a S point, the Smith chart point. But you can make a traditional point if you deactivate the Smith mode here. So I can create a point very near here, and it creates a point with default with a different color, because this is a Cartesian point and this is a Smith point. So you can see the difference between the coordinates. Are very similar in graphical mode, but in the transformation is very different. So when you create circles, is very useful. For example, here I create a circle, and the application is able to create the circle in the code. So, for example, I can create a new program here. So you can log in with you can make use of the app anonymously, and it's a offline first mode app, but you can also log in and see what are your designs. So here I will log in. And I can see all the designs that I made for this user. So for example, here is a very simple application. You can see use colors, as you know that in JSX, and so on. So if I open this, that is very simple. You can see that the comments, and I need to add for make this even more useful, I need to make this code intelligent. So for example, you create a email here. So my email, for example, it recognizes as email, and you can follow, and is open a lot of opportunities to enrich this editor. So in this case, I create this. This is a very typical exercise for telecommunication. It's the calculus of a telecommunication line. So you can see some parameters here, the use of that parameters, some text that I create here. So for example, if I need to match with a different impedance, I can run it again, and it change completely. Okay. I'm sorry. There are some books, random books that I need to fix, but in general, it works. So made some calculation. This is very weird because this is a complex number. So you see here that we are making a division in between complex numbers. Create some points based on that number. Create circles. This circle of here, and so on. So the final result is the intersection between this circle and this circle and the reflection. So you can see here that my final result is the C value. So you can see also here when I change the parameters, all the parameters recalculates. This is very useful for all the telecommunication people. Be able to recalculate all the things. At the end, some miscellaneous things like the language. In my native language is Spanish, so can be used also in Spanish. And you prefer, like me, the dark mode, you can use it in dark mode. So as I mentioned before, one of the most difficult challenge here is to make in JSX this grid interactive. As I showed you before, the traditional is only static, but in this case, if I zoom in or zoom out, this grid recalculates. And the other challenges is to create new elements in JSGraph, like the complex operations, not the complex as is, the Smith point, this kind of intersections like this. These are a very specific. I don't know what is happening that. I think that every live presentation is destiny is to fail, but I don't believe that until now. Okay, it creates this circle. So this is a very constrained circle that makes very weird transformation here, but it's possible in the Smith chart. Okay. So you can see the power of the Smith chart using this. And the final point is the architecture. As I mentioned, I use JSGraph, but also use hosting include fair. So this is a offline first application that you can install. So if you want to install here, it's only PWA application. So you can use it in the phone or in a computer. It's offline because in my university in that moment there are a lot of problems with the internet. So I wanted to make it offline first. So I make it possible. Mm, and I need to make a parser for recognize the code. So be able to recognize this, to recognize every element and to fail if not possible. Okay. So here you can see that it fails and it's not able to run with the error. Okay. So I need to use how you say that I need to reparse the JessieCode language and re-implement it to be able to make this kind of transformation that I showed you before, to recognize the color, this kind of elements, and so on. So it's a parser that fit in this editor and make more useful JessieCode. It's not the basic JessieCode, it's JessieCode with steroids. Is made in React with Tailwind. The elements, the projects are safe in Hasura, and is made in JavaScript, TypeScript. So compare with all the traditional solution, the paper and pencil, and the GeoGebra solution that I made. I think that Senior Smith is more easy in the user experience and more smart because allow you to make more with less. And that's all. Thank you, everyone.